All right, so 12-factor container. If you came to this room for this talk, then you're in good shape. And if you came to this room to maybe like get another hour of sleep, then it might not work out so well for you. But that's cool. Let's get some things sorted out right away. I'm on Twitter, so now you know how to troll me. Anybody else? You can email me if you want. Maybe you disagree with the things that I say, but you want to, write it in long form, really get your feelings out. You can do it this way. That's cool. I also write some things on the internet from time to time and provide other links to connect to me. So you can find that at caseywest.com. Did I spell that right? Yeah, I got my name right. That's good news. Cool. If you're new to the Twitter thing and you're not so hip to hashtags, maybe you're a little nervous about hashtags, I've provided some starter hashtags. You can use any or all of these things. Some of them are obvious, but we also have hashtag real talk, because we're gonna say some real things about how you can run containers effectively, especially when you have to run a lot of them. And also hashtag TIL, which I recently learned means today I learned. So that's pretty rad. Yeah, so let's get this going. By the way, I have 3 coffees up here. So you all, I don't know, you're out of luck. You're out of luck. But this talk isn't actually about containers, so spoiler. Did anyone come here for a container talk? Has anyone heard of containers? Oh, okay, couple. I think this talk is more about operational maturity. There are a lot of things that we can do with containers. Maybe we shouldn't always do them, right? So that's what we're going to talk about, what we should and shouldn't do. And I like to say that you must be this tall to ride this ride. We're going to talk about running a large number of containers. So the things that I described to you about what you should do or what you shouldn't do according to my understanding and my own experiences, which go back beyond my time at Pivotal when I was running Docker in production way back in the day. These are high-level concerns, and it isn't about running 1 or 2 adorable little containers. It's about running maybe a lot of them. So is anyone, I already asked this question, anyone use containers? And I got maybe half the room. So is anyone throwing down and like you're actually running containers in production, and it's okay to cheat and say that you're running Cloud Foundry, so you're totally running containers in production? Anybody? Has anyone done some Docker in production? It's basically the same question, just a different word. Anybody? Okay. I'm just trying to get a sense of the room. Has anybody used a container scheduler, something that makes decisions for you about where your workloads are placed? Get some automation in there. Yeah, a couple of folks. Okay. Anyone know what the cloud is? No, seriously, help me out. Does anybody know what the cloud is? We got a guy who's emphatically like, I know what the cloud is. This is my Docker slide. Sometimes people come to here talk about containers and they want to hear about Docker, but this is actually a broader statement that I don't want to give you a talk that's very vendor specific. So I'm not giving you a Pivotal talk, I'm not giving you a Docker talk. I may describe some capabilities of IaaS providers or container schedulers or container technology. I might use some names, like even Docker. But generally speaking, I'm trying to give you some broad strokes, because the 12-factor principles are pretty broadly applicable. They were written by Heroku a few years back, and that's great. They did a good job of documenting some good design patterns for software architecture, where your software will run better on the cloud when you adhere to them, but they're still broadly applicable, right? So if you came here for a Docker-specific talk, nope, that's not there. But let's get right into it. Anybody into it? Be cool? So I guess I should ask another question. Who's heard of the 12 factors? Oh, that's a good amount of people. That's great. Oh, I love to ask questions where you have to raise your hand. So who here, and you're like, you're ready, you're here. So who here would say that you're a developer doing something like line of business or business value engineering? Like anybody building some stuff that makes money, maybe? Oh, like more hands raised. You're like, we got paid to come here, we better raise our hand. Anybody here in operations? You're responsible for keeping the lights on. So like, that one guy is responsible for all the crap that first group has to produces. That's not fair, but that's usually how it goes. You're an imposter probably if you didn't raise your hand. I don't know. Designers? Designers aren't really imposters. Okay. Product managers? VCs? Anybody? I got some ideas. Nobody? Okay. Let's dig into it. So, first factor, you have one code base that's tracked in revision control, and you have many deploys. So when we think about this factor, the idea here is that we can deploy the same code without change to multiple environments. And this gives us a lot of benefits in terms of portability and repeatability. We know that when we deploy our code to testing or to a staging environment, it's going to be the same code that lands in production. This means that we can't run specific branches with specific configuration. If we're staging and production, you shouldn't have to actually change your code in order to get an application to run in a different environment. This is the first one right off the bat. So, by the way, the structure of this talk is sort of anti-patterns and best practices. It's completely a false dichotomy, but it plays well on the slides. So that's why we're going to do it this way. So building separate images for staging and production is one of these anti-patterns. So I asked you who's used containers and who's used containers in production. Has anyone here built a container? It doesn't take very long. You probably played around with it. 15 minutes, make something adorable. It's your friend. It's small. It's cute. It starts up when you ask it to. It shuts down when you ask it to. It's beautiful. Yeah, so we don't want to build separate containers to run in separate environments. The whole point of a container is that you've got this immutable artifact, this unchangeable package that you can believe it's going to be the same thing when it goes through each environment. And if you have to produce different versions to go to different environments, then things aren't working out. Another way that this manifests itself is with tagging. So Docker makes a very nice interface for being able to tag different versions of a container. This is great for semantic versioning. That's how you should use it. It's not so good if you use it for specific environments. So this is the first thing. So a best practice is to use the environment, like environment variables, which is a pretty simple and easy to understand thing, or even using feature flags. If you have things like configuration services in your architecture, that's another great way to provide custom information about how your application should run in one environment versus another. Has anyone done feature flags? It's a pain in the neck. So they're a good idea, and it requires a lot of rigor and thought in order to implement well, especially if you want to avoid dead code living in your code base for years or even decades. You have to take great care. But they're a good idea. They can help us do things like A/B testing or turning features on and off in our code or in our application without having to change the code. All right, next, explicitly declare and isolate dependencies. So with this one, we often focus on the explicit declaration of dependencies. What are all the libraries that I require? What operating system am I going to run on if I care about low-level things like that? But I think it's also important to isolate dependencies from our application. If you think about the application and everything it takes to run your code as a big triangle, the tip of that triangle is the little bit of business logic that you wrote that actually matters, and everything else is the supporting infrastructure and the supporting resources to make it run, right? And if you drew a line on that triangle, you'd probably find it's really far up near the top, right? So everything you need to actually run your application is pretty significant compared to the application itself. So I think it's important to isolate that so we can manage lower level resources effectively. So what anti-pattern is latest? Who knows the exact version of all of your low-level software that you're dependent on? The exact version of every library? I'm just going to assume that everybody's hand went up, because that's a good idea. Like, that's what I saw. But if you rely on the latest versions of things, then what happens? Like, what can happen on Monday when you walk into the office after a beautiful week in Las Vegas and you try and build your code? You're going to get a new bump to a new major version. There's going to be incompatible changes to some low-level library. Your build breaks, and suddenly your deployment is delayed by a week, right? That's no fun. By the way, it's not delayed by a week because it takes a week to fix it. It's delayed by a week because that's how long it takes the business to trust you again. Kind of a problem, kind of a problem. So we have to declare the version numbers of upstream dependencies. This may seem a little bit obvious, but if you're building an application of reasonable size, then you understand, you already know that this is actually quite a big problem. Dependency management is kind of its own special hell. I love what the Spring Boot team has done to try and take away a lot of that pain for us, for most of the core libraries that we need to work on, or we need to work with in order to build applications. When someone else is doing that pain of making sure that the graph of low-level dependencies all match up and everything works out okay. It's super important. But when we talk about isolating our dependencies from our code, from our application, we should take great care about how we build these containers. So we should build on base images. Now, I already warned you I like to ask questions with hand raising. Out of curiosity, is anyone using Cloud Foundry? Well, that's a decent number of folks. OK. And then people are using Docker as well. And you can use them both together. It's all good. But so the Cloud Foundry model for building a container, I think, is very interesting because it does map to this particular best practice, which is to provide some sort of middle layer to offer runtime environments for your application. We do that with build packs. And then build packs combined with the stager, whenever we push an application, will build a container for us. But it does keep the runtime environment lower level dependencies isolated from our application. And the management of those lower level dependencies isolated as well. So when you want to rev the JVM, fix a CVE, you can do that in a core way, and then rebuild all of the images that run your applications. That's a good model. That's especially a good model if you start building dozens of containers or even hundreds of containers, especially if you have that many applications in your portfolio you're trying to get into an elastic or cloud-like environment using containers. Now, I've done this with straight Docker images as well. And I built a CI/CD pipeline to have intermediate images. Now, I know that we have certified images on Docker Hub now. Well, we didn't have that whenever I first got going. And then you also have to be wary of running images that other people built because you want to understand exactly what's in them. But they provide intermediate images as well. So there's always the Java container that's on Docker Hub that's certified that you can start from as a base layer in order to build a Docker container. And this allows us to rev the base intermediate image with the runtime environment independent from our application and keep these things relatively separated. And that's a good plan, right? So this is a good plan when you have many applications, but maybe they share 1 or 2 or 3 runtime environments. And when you want to change the core, whether it's the operating system, the libraries, the virtual machines, what have you, when you want to change that stuff independent from your application, this is a good plan. All right, we're on to the third one. We're getting there. Only 9 to go after this. Store config in the environment. So here's an anti-pattern. Config.yaml, generating or manually editing property files and placing them on servers. Not so great. If you're building a container, we already talked about this a little bit earlier, it's an immutable artifact for a reason. And the idea of immutability gives us a lot of benefits. It also provides us some constraints that we have to live with. And one of the constraints that people get into is that they've got these XML and YAML files that describe their properties, or they've got an application.properties file, and they want to manually place these things somewhere in the running environment in order to update the way that your application works. This is a bad practice. It breaks the idea of immutability. And generally speaking, anytime we add additional touch points to host operating systems that our containers run on, we decrease portability and reliability in our container environment. So we don't want to do things like volume mount properties files or inject them into the container, right? So this is why something like environment variables comes into play. And we can sort of get environment variables on steroids with things like configuration servers or service discovery tools. So and also don't hard code feature flags. So if you have to actually change some code in order to turn a feature on, not such a good idea. You should extract that, right? It's relatively painless to do. Sometimes we forget about it. And we've got some giant if-else block somewhere. So we shouldn't do that. This one is sort of straightforward. It's literally about environment variables. Like if we think about the principle of doing the simplest thing that could possibly work, like this is the simplest thing that could possibly work. And what I love about this is 30 years ago, somebody was like, hey, if we use environment variables, then we can alter runtime characteristics of an application on Linux, and this is actually a pretty decent idea. Maybe we should do this. And everybody got super excited, and environment variables are everywhere. And then around 10 years ago, 15 years ago, we were like, let's take that environment variable idea, but let's wrap it up in some massive thing and call it enterprise and make people pay $1 million for it. And then we're going to have these large-scale configuration management systems. And then we got back to this again with containers. We were like, oh, those environment variables make it pretty easy to change runtime characteristics of applications that are packaged with containers. So this one's pretty decent. And if I was allowed by the AV crew to drop my mic, I would do that. It's also attached to me, so this would be quite painful. So just imagine it. Just imagine it. All right, treating backing services as attached resources. This is usually one of the first things that we run into, like a brick wall, when we're trying to package an application into a container or make it run, especially on an elastic, in an elastic environment or on a container scheduler that's placing workloads for us automatically. And the reason is if you're not doing greenfield work and you have an existing application that was built to run on servers or on virtual machines rather than to run in a cloud-like environment, then you may have made some architectural decisions that turns out don't actually work very well on the cloud. And one of them is that you might manage state and other information very locally to your application, like on the file system, perhaps. Right? That's not so good for running in the cloud. Turns out doing distributed, large-scale, network-attached storage is a problem that I think only one company has solved and actually offered to you as a service, and that would be Google, with Google Cloud. Their persistent disk technology can actually accomplish this stuff. There are other companies that provide similar tools. They are not as reliable. But this one is super hard. And so the question is it a good idea to keep this practice around, or should we refactor? And generally speaking, we should refactor. So the anti-pattern here that's most notable is that we don't have local disk in a container, especially when we're distributing those containers across a compute cluster. They're being rebalanced and relocated all the time. We can't guarantee that we can manage state on the local disk effectively and that we can do it at a large scale. I haven't seen anyone who's nailed this yet for large-scale container schedulers, except for perhaps running containers on Google Cloud. So this one's super important. So I stole a presenting trick from Andrew Schaefer. When something is really important, what you have to do is you have to make it bigger. And then if it's really important, then you make it bigger again. So we don't have local disk. And this one's hard, because this is where the sweat equity comes in. And I have to tell you the truth about running your applications on the cloud, which is that nobody can provide you a magical solution that requires zero effort to get applications that require things like local disk for state management to run well in the cloud. That you actually need to do some work, and I am so sorry about that. Right? Critical thinking is still required in cloud software. Like, that's how it works. Yeah, I'll go back to that big one. Yeah, go for it. That's a great question. I guess that's a little confusing. It's like a double negative. I may have seen I never saw the grammatical mistake I made. Do not rely on local disk. If you do, it is an anti-pattern. Right. I'll speak more clearly into the microphone. Do not rely. No. Thank you very much for that clarification. Tonight, I'm sure that somebody will buy you a beer and hand it to you, and just imagine that it was me. I appreciate that. All right, so connect to network-attached services using connection info from the environment. So when you refactor your application to use something like a blob store and a real API with a network interface that's reliable and versioned, or a key value store or a document store or whatever it is actually works best for your particular use case, you can refer back to one of our previous factors, get connection information for how to access that state management, and then connect to it over the network. This one is super important. So this is where things like Eureka come in and make this super simple. And then you combine things like Eureka with Spring Boot or Cloud Foundry with Spring Boot, and then you've got it even easier. Like, all the configuration is auto-wired and you don't have to do anything at all. This actually makes it very simple. All right. Strictly separate build and run stages. What I love about this one is that Cloud Foundry gives it to you for free. Or no, not Cloud Foundry. Let me back that up. That was super vendor-y. Containers give you this one for free, regardless of which version you use, what type you use. So when we deploy software, there are usually three primary stages to getting something into production. We have to build an immutable artifact or a package. Thankfully, with containers, we must build a container before we can move on to the next step, which is to deploy that container into a production environment or a production-like environment. And then the third step is to run that thing, right? And these are three distinct phases. But many of us may have an install day or a deploy day when we decide, we all get together and somehow we agree on what we're going to put into production. We all think it's going to work. And then that install day shoves all of those phases together and really muddies the water and doesn't provide clear differentiators. But what I love about containers, one of the things that we get from the constraints of a container that I think is most valuable is that we have to build it before we can deploy it, before we can run it. And each of those things are distinct actions, right? And this is really important. So install on deploy is a bad idea. This is the old model. I happen to be an old school Perl hacker. I don't know if you've ever tried to deploy some Perl software, but you have to do a make install as part of the deployment process and download a bunch of crap from the internet. Maybe you can prepackage that into a container now, and that would be great. I know you can. It's actually not that bad. But it turns out we learned eventually that that's actually kind of a bad idea, but that was a model that we used for a very long time. This is very similar to any sort of modify in place scenario when we try and deploy new versions of software. If you have to drop a jar or a WAR file onto an application server and poke that application server, that's a modify in place. That does not cleanly separate the idea of build, deploy, and run. So this one's pretty simple. Build an immutable image and then run that image. Containers sort of force us down this path. It's very painfully obvious. Here are some other painfully obvious things, just in case you need any of them. All right, so respect the lifecycle. Build, run, destroy. This is the complete lifecycle, not just for deployment. Right? These are what we can do. We have two actions we can do in a containerized environment. We can start a container and we can stop a container. When you want to go from version 1 to version 2 of your application, you have to build a new immutable artifact. And then you only have these two options to work from. So you quite literally have to respect this lifecycle. Execute applications as one or more stateless processes. So this one trips people up sometimes because they're like, wait. Like, our application has state. Like, state is a fancy word for information most of the time, for data. So how can we build stateless applications? That sounds pretty pointless. And I get that. But this isn't about applications that do not interact with or manage state. This is about applications that do not manage state internally to itself, to its running environment, typically, quite literally, in memory, or perhaps on a local disk that might be ephemeral, which is the case in containers, especially if we're trying to keep to that immutable idea as much as possible. So we need to use external services to manage state, and our applications will remain stateless. If they do remain stateless, then we can run many of them. We can put a load balancer in front of it, and then we can handle capacity, right? And this is how we can get things like auto-scaling, which is one of these beautiful benefits of going to the cloud, is the idea of elasticity in our architecture, right? It gets a little bit easier. If you're building immutable containers with a reduced amount of touch points to the host operating system, if you're managing state externally from your application, then you can spin up a lot of instances of that application, and it's going to be generally OK. There are some places where we run into different types of scaling issues later on, but for the most part, this is great for getting started. So I would say one of these best practices is to schedule long-running processes by distributing them across a cluster of physical hardware. So I know that we're a bit further down the road from people having servers in closets and calling that production. Don't raise your hand if that's you. So we're a bit further down the road from that, but in development, we're not. Right? So if we're actively developing software, and I'm going to go ahead and tell you that this has happened to me. I have actually committed this particular crime. I have developed software on my local laptop. I thought it was pretty good. It worked on my machine. One of these great, famous last words that we say. Then we tried to deploy it to production, and we were running more than one instance in production. And it turns out it didn't work very well because for some reason I was managing state in memory in my process, and I made a mistake. So this is in particular for developers and for testing environments, for staging environments. It's just as important, maybe even more important, for us than in production, because chances are in production you're running a collection of instances for high availability for your application already. But I bet we have run into a bug that it turns out we were just doing something in local memory. We forgot to send it to a shared distributed cache, or we forgot to offload it to some other external state management tool. So in a developer environment, you may not have a collection of VMs or something available to you, but you can still spin them up on your local laptop. And then you get the network in between each of your services and in between each of your instances, which mirrors production a little bit more, which can increase our confidence even further that what we're building is probably not going to break when we shove it out into production. And increasing that confidence is really, really key, right? That's what's super important. An anti-pattern here is trying to recreate or use things like NFS. Now, I'm not really a big fan of NFS when you're trying to go to the cloud or an elastic environment where maybe you're changing the shape and the size of your compute cluster, and you've got a container scheduler that's balancing your workloads for you, redistributing them, because this thing just does not end up scaling and performing in that environment. But if you're not willing to adhere to one of the previous factors, I think it was number 4, where we don't have local disk available to us anymore and we may have to refactor our application, then you end up trying to shoehorn things like NFS into your production environment. And you're going to find out that this is going to be one of your bottlenecks, and your choke points is going to bring down your application pretty quickly. I don't want to say any more about it. I just want to throw that out there. So we should export services via port binding. And when we say services, this actually means our services, the applications we're making. If we're supposed to connect to backing services over the network, and we want to provide good interfaces and protocols to interact with them, the same is true for the applications that we build. So we should expose them on the network through port binding. We should not expose them through like shelling out or anything cool like that, right? That's old school, amateur hour, and we need to use ports. Now, this one's relatively easy to accomplish. Again, like this is mostly unnecessary to even worry about with frameworks like Spring Boot at your disposal. But most container runtimes will tell you what port they expect your application to listen on and respond to requests on, and you should just pay attention to that. So we can use one of the previous factors, like environment variables. Now, I know I'm at Spring 1, but here's some Ruby. That's a best practice for this one. Hey, here's some Perl. Anybody getting excited? Here's some super low-level Java at this point. But it's pretty simple, right? You can inspect the environment. You can get the port off of the environment. This is a pretty typical environment variable you're going to find when you run an application in a container, especially if you have a container scheduler. If you don't have a container scheduler, you can provide this port, right? And we already know how to do that even in local development when we're spinning up a couple of applications to work together. I don't know if anybody's into Rust. It's a pretty cool programming language. Now you know some Rust. That's cool, right? So this one's pretty easy. Scale out via the process model. So we've already talked a little bit about the value of having a stateless process and being able to replicate them in order to increase the amount of capacity you have to handle load. And we should be able to increase it. So the way we do that is just by running more instances of that container. Right? And they're immutable, so they never change. If instances need to have some particular characteristics or some particular information as part of your cluster, you can provide that with environment variables or configuration services. You can attach to them over the network. You see how these things sort of build on top of each other now? So we can horizontally scale by adding instances, right? Now, if you're using, something like Kubernetes, Cloud Foundry, Mesos, just Marathon, Nomad. If you're using, what's the other one? Oh yeah, Docker, Swarm, something like that. Like they give you one of these capabilities, or a lot of this capability kind of out of the box. Some of them have auto-scaling capabilities right out of the box as well. It's pretty nice. Then you can provide some constraints in order to understand where the thresholds are to scale up or scale down an application. Scale up to handle increased load expectations, scale down to save money when the load is low. This is all good. And if you adhere to more of these, the previous factors, then you're going to find that this actually gets quite easy. If you avoid adhering to some of those previous factors, then you find out that this becomes quite challenging sometimes. I don't know what your current life looks like when you want to, say, double the capacity for a particular application in production, but it may involve finding somebody who knows which version of the golden image is actually the one that we should try and spin up a couple of instances of. Then they have to go on and manually configure a few properties on each of them, like host names and stuff. Then maybe run configuration management on them, get your application in there. Schedule a maintenance window with your load balancer, because we don't know how to really programmatically change the load balancer without taking it down. And then, a month later, you have double the capacity. That doesn't really work in a cloud environment. We need to move a little quicker than that. And I've heard that story play out where it isn't a month, it's like 6 months, or it isn't 6 months, it's like we would never ask for that because we would never get it. So that's pretty rough. But containers make this a little bit easier. So, all right, maximizing robustness with fast startup and graceful shutdown. I like the fast startup thing. I think it's way more important than we give it credit for. And we can, as developers, shoot ourselves in the foot with this. But the reason that we need to start up quickly is about that scalability and the elasticity we can get from running applications in the cloud. Containers make that kind of easy already to run them. But why would fast startup be important? Well, what does your network graph look like when Reddit or Hacker News finds out about your application and it takes off and then suddenly everybody goes to it right away, right? You've got this huge spike. Now, does anybody else remember /dot? Who's old? Me too. Me too. So I would have called this a /dotting, but I recently learned from like a 19-year-old intern up in Boston that people don't say that anymore. That it turns out, and by the way, if you take nothing else away from this talk, hear me now. They call it the hug of death. The hug of death. The hug of death is when everybody likes your app so much that they destroy it. Right? So that's super nice. Thank you for the hug of death. Got to cycle my coffees. Give me just a second. So when the hug of death comes your way and your application falls over and your leadership team's like, so our application got super popular and now no one can use it, so guess what, it's not popular anymore? Like, that's a bad day, right? No one wants to be in that meeting. So one of the things that we get with the container is this idea, and with the cloud in general, is this idea of elasticity, and we can take advantage of that. If we build our application to take advantage of that, if we package it in a way that makes it easy to dynamically scale, then we can inspect incoming network traffic and understand that we're getting a spike. This may be significant. Increase the capacity automatically. If we have a load balancer that we can programmatically update in real time, then we can get this stuff into the pool and we can start handling those requests. And when they taper off, we can start bringing down the number of instances as well. Right? So that's super important. That's why fast startup is important, because if it takes 15 minutes for your application to boot up because you're hot loading maps and maps and maps of data out of your database because it's so slow to query it at runtime that you thought startup time doesn't matter, so we'll just front load all this and use 16 gigs of memory. Like, that's, by the way, like, I get it. I was there. I've made that trade-off, but that ends up crushing you when you want to have dynamic elasticity, especially if you're trying to handle real actual events. Incidentally, your network graph looks the same if some people try and take your app offline on purpose because they don't like you and they try and DDoS you. It's the same thing, same big spike. It's basically indistinguishable. There are some ways to distinguish, and there are other ways to account for that in addition to spinning up instances, like having edge caching layers like CDNs, maybe even really good dynamic CDNs. Like, there are some other things that you should do as well. But this is super important in order to get that sort of elasticity. Now, the other thing that is not highlighted here is graceful shutdown. And this harkens back to the idea of stateless applications. Because if we are managing state internally in memory, one of the pain points of that, or in an ephemeral environment, one of the pain points of that is that if your application does crash or die or burn, or use your word of choice, then you may end up with a corrupted environment. You may drop a transaction on the floor. You may corrupt data. Right? And this is a bad time. So that is not graceful shutdown. So graceful shutdown is being really careful about things like transaction management, being really careful about offloading data into backing services that are specifically designed to manage that information or manage that transaction. So I don't really have a best practice or an anti-pattern. I just like talking about that a lot, so that's what I did there. So we should keep development, staging, and production as similar as possible. This is super easy when I have a laptop and operations has like a data center full of racks and racks of servers. It's super easy to keep these things basically the same, And I had a talk earlier where I told something that I suspect people think is a joke, which is a story about how in a meeting I demanded that my operations team ship my laptop into production, and that really is a true story. Because I got it working on my machine. But containers give us repeatable software. So if we have immutable artifacts, if we really have built an immutable container, then the same one that's running in production we should be able to run in our developer environment, right? And then we can have some confidence that our application actually does work with the interfaces, the APIs, or the contracts that are available to us with what we think is actually stable and running in production. You don't have to guess. You don't have to check out a branch and hope it's actually the same thing. You don't have to worry about specialized configuration properties that nobody told you about. You can have a similar running environment in development. So I would say run containers in development. And tools like Docker Machine and Docker Compose make this pretty simple in a Docker environment. If you're rocking the Cloud Foundry, you can use things like PCFdev to actually run your applications. Now, you don't necessarily have to run your complete microservices architecture in your developer environment, but you can run your network neighbors, your architectural neighbors. You can run the services that you depend on. You can also run the services that depend on your application, right? And this is a really good practice. And that way, you have real confidence and real knowledge that your application works. Your integration is real. Right? There's nothing worse than integrating to something that actually isn't the thing that runs in production. There's nothing worse than saying, but I thought it worked this way, look at my machine, and then go into production and realizing that it's something else. So run those containers in development. Number 11, treat logs as event streams. This is one where I think we sort of over-architect some of the time our logging layer. Like who's enjoyed like really digging in and building a robust logging infrastructure so that your application can log everything? Anybody? We're beyond that. Oh, that's exciting. I think it's very similar to the templating layer. Like everyone's written their own templating engine. Everyone's probably also written their own slide tool. Like when you have to give a talk like this, you're like, before I do that, I have to write my own slides. Or my own slide tool. But logging is something that sometimes we over-engineer, but containers make this pretty easy. When your application runs in a container, it runs in the foreground. So it's not a daemonized process. It's not necessarily pre-forked, but you have everything running right there in the foreground. It's sort of process zero inside of an isolated environment. So one of the things we can't do is shove random log files all over our file system and then make people SSH in to all these servers in production and figure out where the log file is for this particular business application in order to figure out what's going on when something goes wrong, right? We can't do that at all. Instead, yeah, bro. Instead, we can use the tried and true standard out and standard error, right? So in your logging configuration, just let it do the simplest thing that could possibly work. Don't try and overthink it. Don't volume mount a log directory and then start spewing stuff into your host file system, right? This is a pain in the neck for everyone, and it's a harder to manage system. Instead, we can log to standard out, and then we can stream these logs and provide them to something like Logstash or the Elk Stack or Splunk if you're into that sort of thing. You can go that way too. And this is really just like the simplest thing that could work, but it is far and away the best recommendation. I should mention on this in particular that when it comes to microservices architectures, we have some cooler tools available to us than just doing something like standard out logging. So we can use things like Zipkin distributed tracing. We can get really sophisticated specific tracing for specific business processes, and then we can forward those things on to tools like the Elk Stack or the Logstash, and that's actually pretty fantastic. So if you aren't using Zipkin, I highly recommend giving it a shot. Oh wow, we're already at 12. This is great. There was like 5 minutes in between sessions today, so I was asked very kindly by the AV crew if I could make it 10 minutes somehow. So I am trying to track to that. That'll give us a jump on the other people who need more coffee. So that's pretty exciting. So we should run admin and management tasks as one-off processes. This one ends up being a little bit challenging for us sometimes. So I'm sure that we have to do things like database migrations are the type of admin process that you have to run once, and then you probably don't actually run that thing again in your production environment. And that's fine. Those are usually the easy things to do. Maybe you need to manipulate some data a little bit, do some finessing. Sometimes we do that with one-off processes. Now the problem is, more often than not, while we pride ourselves on writing object-oriented, amazing, beautiful code with great tests for our application, when it comes to our one-off processes, we write doit.sh and give it to somebody in operations, and then they upload it to util01.prod, right? And then they run that thing, right? Who's written doit.sh? I have. I have made that sin. That is me. So why do we do that when we're craftsmen and craftswomen? Why do we do that when we have actual code and tests at our disposal? What if we designed one-off processes with the same rigor that we designed the rest of our application code? And what if we built it and tested these processes with real unit tests, and they went through CI and CD and they got code reviewed? What if we did that? What if we wrote a class to encapsulate this functionality, or a particular function to encapsulate this functionality, and we actually got it into revision control with a commit message that made sense? That's not a bad plan. We already know how to do that, so what if we keep doing that? Now this is important because then your one-off processes are something that you take as seriously as the source code that's actually running your production environment. And we can do that as part of our application, and then we can take advantage of the source code and business logic and business rules that are already built in to the application that we're building. So this has a lot of benefits, and we're getting further down the path. Now, one of the other things that we do, aside from doit.sh, is we write some massive management, /admin, system, and /admin gets littered with basically doit.sh in web form, and then you build some button that somebody has to push in production. But we don't have to do that. We can find a nice middle ground. So the anti-pattern is don't build custom containers for custom tasks. Don't wrap doit.sh in a Docker container and then try and run that on the cluster. You already have the application in production, and you already have built an image for that application. If your one-off processes or admin or manipulation tasks are already encapsulated in your application, then you can reuse the application image, and you can just provide an alternate endpoint for how to run the source code inside of that container. Your alternate endpoint can be a particular, Maven or Gradle task, or it could be doit.sh if you really wanted it to be, but it should live with the source code. This ends up being pretty powerful because we have long-running processes, which is typically what we're running when we're building services and deploying them into production. But containers are good for short-lived processes too. And the only difference between a long-running process and a short-lived process is that when a short-lived process dies, we don't think of it as an issue. It's not a bug. It's a feature. And when a long-lived process dies, we think of that as a problem, and we want to start one back up in its place to keep our application alive. But we can provide an alternate entry point, an alternate starting command. We can do things like this for running tests as well, and then you can actually run your unit test suite inside of a container in the type of environment your application is really running in. Right? So this ends up being really powerful. And then you can plug that into your CI/CD pipeline, and you can have an even higher degree of confidence that your application is probably behaving properly in the actual environment that it's going to run in when you deploy it to production. Congratulations, everybody. I didn't realize we made it this far. OK. So you're all cloud natives. Congratulations. What does that even mean? But I think that the reason that I care about this and the reason why I think it matters is because this is what we want in our production environment, right? This is what we want when we're managing large-scale software. We want repeatability, reliability, and resiliency. And if we take advantage of all of the whiz-bang features we read about in documentation about containers, then we might find that we shackle ourselves to a really poorly performing system. We don't have repeatability, we don't have reliability, and we end up without resilience in our software architecture. So let's remember that the constraints that are in place in order to go to the cloud actually work to our benefit. Right? Then our production environment can keep its promises about how our application is going to run. But if we take shortcuts, then we will not actually get to see some of the benefits that people are talking about when they say containers fix all my problems. It's not quite right. And you have to take care, and you have to use critical thinking, as I mentioned before. So, all right, we're here. So I am Casey West on Twitter. We can be friends online or in real life, which is why I've got the beer emoji. That represents real life. Although I'll be honest with you, had all the beer for today last night. So we might be drinking some water. I do have about 10 minutes if we have any questions, or I can let you get coffee early. Questions, comments? Yeah.
Everybody keeps talking about the 12-factor album. Everything that holds, they try to fit in this 12 factors, but I feel like, there's more than 12 factors. For some reason, we keep sticking to that. I mean, that's fine, right? It's all good. But,
right.
Especially with containers, I feel like there's more dimensions than that.
That's a good point. So the comment, not so much a question maybe, but definitely a comment.
The question is, what do you think beyond 12 factors, right? What else is missing? Because I can think of at least a couple off the top of my head that might be very important that are not covered by the 12 factors.
Right. So the comment here is we try and shoehorn our applications into this 12-factor model. Maybe it doesn't work for every situation. Maybe there are more factors. Maybe some of them don't even matter. That's true too. Yeah. And I agree with that. This is a good abstraction for general cases, but it does not apply to all cases. Just like we like to talk about virtualization being something that can just work for everything, but then if you're doing CPU-intensive applications, that's not the case anymore, right? And then we don't get those benefits. There is a book, a small book that was written by, I cannot remember his name, Kevin Hoffman, that's beyond the 12-factor application that describes some more capabilities. I will totally admit to you that right here on stage, I can't think of any more off the top of my head because I was focused on these 12. But I will take your suggestions and I will repeat them.
I can think of don't run your database in a container, right? That would be one of them, right?
Okay.
Don't run your container as root. It's similar, but don't run.
Right, so some more low-level stuff. So you mentioned don't run your database in a container. Don't run your containers as root. I think these are good models. So back when I ran Docker in production, everything was root and everything was privileged access, and that was a little bit scary because I was doing it at a web security company, and people didn't like that very much. You should run your applications as best you can in an unprivileged mode in containers. That's true. As far as running your database in a container, I also agree with that, broadly speaking. We still have to manage long-term state, right? And if you try to run a container, a database inside of a container, you're going to find that you're going to have to volume out most of the actual critical stuff. Then you're tied to your hosts, and then you're back into the same situation where what sort of benefits are you getting from isolating the running processes inside of a container environment when most of the stuff that you actually care about is the data that you have to manage? I also do know a handful of people who are trying to cram Oracle databases into Docker containers and run them on things like Kubernetes or even Cloud Foundry, and I wish them the best of luck. But yeah, that's not gonna get you any benefits either. Does anybody else have any ideas around additional capabilities or characteristics that you would want to add to this list? Because I don't know everything, and I want to hear from everyone else too.
I have a long review blog post to talk about. There's a bunch of things I don't even mention. One of them is probably security, repeatability, other aspects of
Right. So Andrew will write a blog post someday, which will make Kelly very happy. Yeah. Right. Yeah, that's a good point. This is still kind of a nasty problem for a lot of environments when we try and deploy and manage containers, is how do we do things like secrets management and certificates, especially when you're trying to deploy maybe with some measure of automation, and you don't want to break the immutability aspects of the container. So we can use things like console, to manage our secrets, and we can connect to them as part of our application or even our boot sequence and get information down that way. But also people are using configuration management a lot of the time to lay down things like init scripts or systemd scripts, whatever you're using to basically start up these processes. And that's cool. That's a nice intermediate step. Tools like Cloud Foundry with Bosch allow you to provide some of these things at a lower level way where the automation is sort of baked in. You have to, as an operator of the platform, you have to manage the certificates and some of those low-level secrets yourself, but then you can inject them into the running environment for applications to take advantage of. This is still sort of a gnarly thing, but generally speaking, use a good secret management or a secret database. Something like Console is going to serve you well. Yeah.
You want to say console plus Vault, right? Not just console.
Oh yeah, sorry, Console plus Vault. Yeah, that's correct. Questions? Anything else? We good? Thank you. I really appreciate your time. It's 9 a.m. and this is like crazy hard to get up today, so thank you so much. Yeah, cheers.